Hello, AP Stats students, and welcome to Trimester 3, in which we are going to start Chapter 10, which is all about comparing two populations or groups. Chapter 9 was significance tests, and I wanted to show you that there have been Chapter 9-like free response questions on AP exams in the following years. So in the following years, there was a question on the AP exam that was basically a Chapter 9 question. You can see this is a pretty long list. There were a couple years where they gave two different versions. In 2009 on Form B, there were two different questions that were Chapter 9. And then I've mentioned the Chapter 6 problems, and there were Chapter 6 problems, not Chapter 6. Question number 6 from the AP exam, which is a little more of an exploratory for response question. And they had problems related to Chapter 9, as question number 6 is in the following years. So you can see this is a pretty decent list. Most years there is something related to Chapter 9 on the AP exam. However, the only chapter with a longer list is the chapter we're about to start. You can see in all of these years, there has been a free response question related to Chapter 10 content, including last year and the year before. Not 2017, but yes, 2016 and 15. So you can see 4 of the last 5 years there's been a Chapter 10 question. And question number 6 you can see a few times. So Chapter 10 is about comparing two populations and groups, and Section 10.1, which we're starting today, is about comparing two proportions. So basically, in Chapter 9, when we were comparing things, we were comparing to some null hypothesis that we had a conceived notion about. That's not always the case. Sometimes you want to compare two things to each other, and you're not sure what values you'll get for either one. So if you want to compare two popular drugs to lower bad cholesterol, you would give both drugs to people in some sort of randomized study. You look at the two groups, and for one group, the proportion that had a heart attack or suffered a serious consequence within 2 years was about 26.3%. Those in the other group was 22.4%. And we want to compare these two groups to each other instead of some percentage that we set ahead of time. Now the thing about this is both of these numbers are from samples, so they are both statistics, and neither one is a parameter. And basically, could we have seen this big of a difference between these two drugs just by chance because of random assignment? That's basically an example of comparing two proportions to each other. Comparing two means, who studies more, men or women? So researchers asked separate samples of 30 females, 30 males at a large university, how often they studied. The females reported studying an average of 165.17 minutes in a typical weeknight, while males average 117.17. So this is a pretty large difference, or not? Could that have happened just by chance? Again, we're not comparing them to some null hypothesis value that we had ahead of time. We're comparing them to each other. This is one of the most common situations encountered in stats. And that's what we're going to be looking at in this chapter, starting with an activity we're going to try to kind of do online. Yay! Is yawning contagious? Did you just yawn? Did you? Because I yawned and you saw that picture? Well, to investigate this, the people on the show Mythbusters conducted an experiment. Basically, each subject was placed in a booth for an extended period of time and then monitored them by hidden camera. 34 of these 50 subjects were given a yawn seed by one of the experimenters. What that means, if you received a yawn seed, that means that the experimenter yawned while the subject could see them in the presence of the subject before they left the room. The other 16 subjects did not get a yawn seed, so the experimenter did not yawn at them. What happened? So did the people that get a yawn, were they more likely to then also yawn? So here are the results of the experiment. And you can see that when they were given a yawn seed, when the person yawned at them, 10 out of 34 people proceeded to yawn, which is about 29.4%. Of the people that were not given a yawn seed, only 4 out of 16 people yawned, which is 25%. So you can see that this number is slightly bigger than this number. But 4.5% bigger, is that a big difference or not? Well, the hosts, Adam Savage and Jamie Heineman, and co-hosts, used this data, and they looked at this data and concluded that, oh my gosh, this number is bigger than this number. Yawning is contagious. So we're going to take a look at that analysis right here. Is that conclusion actually legitimate? So what we're going to do is we're going to see what would happen if we just randomly assign these 50 people to groups that receive a seed or don't. And we're going to do this many, many times. We're going to assume the treatment did not affect whether or not the person yawned. So if we were in person, we would use a deck of cards, but instead we're going to do this. On my page that you already went to right here, you can see there's a simulation applet. Go ahead and open that, and you can see here that this is what we're going to use. You can see that these numbers are exactly the same. No, they're not exactly the same. I need to adjust them a little bit, I think. So, subjects that yawn, yes, yes, should be 10. You will need to do the same. And then subjects that didn't yawn here is 24. And then here we had 4 and 12. So those are the numbers we're going to be using. And what we're going to do is we're going to basically, this will simulate taking a deck of cards, assigning basically 14 of those cards to be yawners. So those people are going to yawn no matter what group they're given, and 36 people are going to be people that do not yawn no matter what group they are assigned to. What I'm going to do is I'm going to show shuffle options, and basically I click shuffle, and it's going to take those 50 people and assign them, some of them, to group A. So that's 34 cards. You can see when you add those up, it's 34 cards to group A and the remaining 16 to group B. And you can see of those cards, 8 of them were successes, and that would be yawners, and 26 were not yawners. In group B, so those that did not receive a yawn seed, 6 of them were yawners and 10 were not. If you subtract those, you can see we get a difference of negative 13%. Now in this here, there was a difference of about 4.4%. So you can see we got a lower difference. What I'm going to do is I'm going to do this again, and I get a new difference in the proportions, and again, and I get a new difference in the proportions, and again, and again, and again. Now, if we were in class together, we would be, each doing a number of simulations and compile our results. But since we are not together, you're just going to have to do this a whole bunch of times and get a whole bunch of results. You'll notice one way you can, speed this up is to just change that number to something really large, and then you can get a whole lot of simulations. Okay. Once you have all those simulations, what I'd like you to do is you're then going to answer some questions about those simulations. So you can see that the Mythbusters got this difference. Okay. So in what percent of your simulations did the difference in proportions equal or exceed that number? So how many times did you get a number more than 4.4%? So something, and you can actually have this applet count these by filling in the number you want to count of greater than or equal to right here. So type it in as a decimal, 0.044, and hit count. And it will tell you, hey, that's how many times I observed a difference that big or bigger. Then what you're going to do is you're going to go back to My AHA, and you can see there are questions about the activity. If you click on that link, it'll bring you to a document here. Actually, I'm going to add a question here where you type in the percent you got. So I got, what was it, 50%, I think. So I'll type that in here, but then I'm going to answer these questions. So based on those results, how surprising would it be to get a result this large or larger just due to chance? So basically, are you surprised? How surprising would it be? What conclusion can you draw? This is related to p-value. Explain why you would draw that conclusion. And then based on that conclusion you just made here, could you have made a type 1 error or type 2 error, and explain what that means in context. You'll then submit those responses to me, and I'll read them over later tonight. Then the only other thing I'd like you to do today is make sure you fill out your attendance ticket. This is how I know that you read my instructions and know what you need to do today. And then just a comment on homework. Based on today's lesson, you probably can't start much, but here's the list of homework for this chapter that we'll be getting into. Based on tomorrow's lesson, you'll take some more notes and be able to start homework 10.1. As always, email me if you have any questions.